Okay, so I can see from, well, morning, everyone, or evening, depending on where you are. At this end, I can see we've got Steve and Rob. Are you in Australia or in the States?
I'm out at Ilford, Waroona, at the out here in the west of Sydney, and in the last hour we've had four seasons: winter, summer, fall, and spring.
Yeah.
But I'm here in Australia.
All right, so we'll count you in on the Australian side. Len, I can see. So as I said, I've only got half an hour, and I've got grandchildren duties. The trouble is, if you have five grandchildren, you have to keep going and doing things. So from my perspective, yes, so there was the my contribution to the Eastern Conference. Now, I was hoping that we might have the video for that, but as Rich was saying, there were problems with recording some of the papers from the Eastern Conference. So I will redo that recording and get it right. And then Rich will circulate the link to that recording. So the gist of the presentation was just to introduce US friends to what's happening here. So I basically started with a map. Where is everyone, basically? And if it was the other way around, I'd certainly need a map of the US to work out where everyone is. And we've got representatives from New South Wales, Victoria, Tasmania, South Australia. And the plan at this end is to try and broaden that to see if we can find some other radio astronomers around the country. That's my longer term aim. Once work keeps getting in the way, that's the trouble. They've just given me some more work. The other one is a paper I'm going to be developing for the physics conference, which comes up in early February. I've been doing a paper each year for that conference. That's physics teachers, year 7 to year 10, and also year 11 and 12, the senior years of school. And the first one I did was astronomy during the school day. That's on YouTube. The second one early this year, was particularly radio astronomy. And what came out of that paper was teachers looking for ready to go materials. So this time around in early February, I'll do something on space science, and I'll find some materials. I've already got some, and I'll make some materials which can be used directly. I'm choosing space science because there is a lot of information. For example, our own Bureau of Meteorology has its own space science section on their website, and NOAA has a similar section, and then NASA has its own. So there's quite a lot of material out about space science, and I'm going to pitch it that we're about to hit the sunspot maximum, and certainly in Australia and around the world, we've been getting massive auroras, Australis and Borealis, and I want to sort of tie those two together, get students thinking about, well, why are we getting auroras? Because of the sunspot cycle, and what are the implications for that if there were to be some massive storm which hit Earth, took out electromagnetic, or took out our power systems or took out satellites. So have a think about that while we're at a sunspot maximum. So that's the plan. That's basically where I'm aiming. Len, thank you, Len. Just lent me a couple of books, and I'm working my way through one of them, which is about the development of the Parkes telescope. And that might be of interest to people at some point as well. So that's the development of radio astronomy in Australia, then around the world, and leading to the design and development of the Parkes telescope. So those are my current projects. I think Steve might be able to fill us in on the Astronomical Society of Victoria dish. We've just had an update. We had a meeting on Monday, and we've had an update about where that is up to. And then Duncan's probably got something to share with us, and Len. So we'll start with Steve. Steve, if you can give us a quick update on the state of the dish and anything else you might have up your sleeve there.
I don't have a great deal, Paul. I think Phil Costigan was joined last month. Is that correct?
So he was with us last time. Yep.
Yeah. Well, not a lot has happened since then. The reconstruction of the worn-out altitude worm drive. We've got this system where you've got a jack screw that's lifted up and down through a worm drive gear, and that worm gear wore out after a couple of years' use. And I must admit I'm partly to blame because it was during the pandemic period and I was driving it quite heavily and getting some results and writing reports. So it was being used, but it had a few defects, not the least of which was little weld splatters along the thread of the jack screw, which was accelerating the wear in the phosphor bronze gear. So we've resolved all of those problems. We've built a new phosphor bronze gear, and we've got a replacement one, a spare one as well for the future. And there was a big job of lifting the whole assembly back up onto the tower because it weighs a ton or more. And that was done by actually using the worm drive gear itself. So an attachment was made so an electric drill could go into the worm gear and actually winch this whole assembly, which was a big heavy metal swivel plate that holds the worm gear system and the motor drive system for the altitude jacking. That whole thing was lifted up by rotating the worm gear using an electric hand drill. And then it was a matter of fixing it all at the top. It's pretty much assembled at the top. There was one bolt that holds that swivel plate to the top tower, one bolt that didn't go all the way home. And that's because it's a very fine thread that was used, and that was full of gunk, needed to be cleaned out, which is going to happen soon. And then that bolt can finish off fixing the whole assembly. So that mechanically then is complete. The last step done, well, there's two steps really, is to run the thing through its paces, jack the thing up and down, what's called rehoming the dish. So it's got to go down to its horizontal position and then a little bit further, set that as a limit in the software, and hopefully when you do adjust the dish, it never goes beyond that set point. Phil wants to do that because it's been a couple of years since he's worked on those motor drive systems. It was his design. And we want to make sure all the gears mesh properly and the thing gets a bit of lubrication through the system. But then once that's done and we're satisfied we can control the dish, the jack screw needs to have dust covers. And this was one of the exercises of the restoration work, was to prevent gunk and bad weather getting onto this jacking screw. And you need to do it on either side of the worm gear because the worm gear goes over the whole jack screw. And so you'll have a section at the bottom and a section at the top. The section at the bottom has already been covered with its collapsible bellows, but the section at the top has not been done yet. So that's the last step mechanically to restore that dish. And it'll be no mean feat because you'll have to adjust the dish so that the jack screw is almost fully extended, so the dish will be pointing horizontal. That makes sense. And someone needs to be up on the tower, strapped in with a harness or something so they don't fall off. It's 5.5 meters above ground. And then they need to unzip the bellows and slowly stitch it up over the top of the jack screw, which again is a little tricky to do. We think we can do it. It's a tedious process of getting the zip over each of the leaves of the bellows. Once that's done, we pull the scaffold away, bring the dish down to the point where the feed point can be accessed, get the scaffold in place so we can go up and work on the feed point. And then there's work to be done inside the cabinet at the feed point. We need to reinstate the receiver, the neutral hydrogen receiver. But because of my redesign, which I presented a year or so ago, where I stabilised the front end and the low noise amplifiers and thermally by putting in Peltier cell cooling, and we need to have an airflow system through that cabinet. So additional holes need to be drilled into the cabinet to let air in through ducts. Then these cylindrical ducts will go over the heat sinks where the Peltier cells are, and then the hot air that passes through that heat sink will then go out through another hole. So we hope we get an airflow through the cabinet that's manageable. It'll never be perfect, and one of the complications we face when we're doing that is the weather could get in some of these holes and possibly insects. So we're going to have to, or birds. So we have to put barriers in there, mesh covers and so forth to stop various vermin getting in there. I'm sure we can stop the birds, but I'm not so sure we can ever stop the wasps. There's a tendency for wasps to develop nests anywhere up there on that property in Heathcote. And if you make the mesh small enough, it might be too much of a choke for the airflow. So it's going to be a compromise we'll have to manage. So that'll be my receiver's all finished and ready to go. It's been sitting in the shed up there at Heathcote for a year or so, and so it'll be my job then to commission that and get it working. I had it all working on the bench a year or so ago. I'm satisfied it works. I've written reports about that. So that'll be exciting. I don't think it'll happen until work on those last stages of that restoration will occur until later in September, Paul. I personally will be on a skiing holiday, would you believe, in the Australian Alps in early September. So I won't be available until later in September to help with that. But we're getting into our warmer months, our springtime, and a lot of us will be very eager to get up at Heathcote and get things going again. So that's where we are with the dish. It's progressing, and I'm hoping we'll start to see some significant results, certainly before the end of the year. Is that all right, Paul?
Sounds very good to me. Thank you. Yeah, it's back on again. Yeah, so real progress. Thank you, Steve. It sounds like we're getting very close. Phil Costigan was a bit coy about exactly when we might be back on the air. I think it depends on, depends on availability of people. It's 2 hours drive and more out of Melbourne, so it's a question of availability of people to go up there and do the jobs that are required.
There's certainly people that are keen, though, Paul.
Yeah.
One of the key players is Dr. Tim Davis, who's a physicist, and he's currently working for the Stuttgart University. So he's over in Europe at the moment. And he's going to be the key man to write the software that'll do the controlling of the dish and collecting of the data in an automatic process. Yep. So we don't want to go back to the old days of collecting points manually, which we did. That's what I did personally during the pandemic years. I did it from home. So it was all remote controllable, which was wonderful. But the strategy will be to collect data automatically. And the other thing I can reiterate about the revised receiver, we've now got a reference noise source. So as well as stabilizing the low noise amplifier, the front end, all of that should be a lot more stable and a lot more predictable what it's going to do over the temperature extremes. We've got this low noise reference, which we can toggle to regularly to compare our results with that. So we'll be in a much better position to get meaningful measurements that are repeatable. And Tim Davis will be a key man. He's a whiz with software. So we're going to. I need to rely on people like that who've got the mental acuity to write code almost on the spot and get a result. So I've seen him do it. Phil Costigan's a bit that way too, but Tim's going to do some more clever stuff with the receiver measurements. So there's a bit of maths in that. So that'll be exciting, and Tim Davis is certainly keen to get going as soon as possible.
Very good. I mentioned earlier that I've been given some more work at school. It's in fact teaching programming in Python, would you believe? So I'm on the learning curve now to learn a bit of Python, but I'm very pleased that at this stage it's only year 8. So year 8 doesn't get all that far with Python, but they're starting out, let's say, and so am I. Quite a big learning curve for Python, but there we are. I mentioned books from Len. Thank you, Len. And I'll just draw attention to them. Oh, hang on. Do the right thing here. This one is Beyond Southern Skies, Peter Robertson. And this one is really a synopsis of radio astronomy in Australia and then around the world, including Green Bank, and then into the design and building of the Parkes radio telescope. And then it finishes off with what they've discovered via the Parkes telescope. Great book. Thank you, Len, for dropping that in. The other one is the invention that changed the world about radar. Robert Bodnar, and I haven't started on that one yet, but Len might have some thoughts on that one.
That's an excellent,
yeah.
That's an excellent book for putting things in perspective.
Yeah. I think the link between radar and radio astronomy is very strong. And the other one I will mention at this point is the offer that came out of the Green Bank, out of the Eastern Conference of Green Bank, with the series of lectures from Felix Lockman, J. Lockman. That was a very, very good deal. Rich, you might want to reiterate what that deal is, but I've now subscribed to those lectures. There are 24 of them in this set of radio astronomy, observing the invisible universe, and they are excellent. They really, really are. And I think for us it was like $30, or it might be 30 US, I can't remember. But massive discount through the Great Courses group. It's called the Great Courses, and that's Jay Lockman's presentation, including he does a tour of Green Bank Observatory, and including the massive 2-acre dish, as he puts it, with the offset feed. It goes right through, starts at the bottom, describes the whole thing, goes up in the lift to the radio room, and then up on top of the radio room, right up to the top feed. And I was talking about this at our local meeting on Monday, and it's an offset feed. So there's the dish itself, and as Jay says, it's two acres, whatever that is. I think it's 100 meters by 110, something like that, and then an offset feed here. So then there's a reflector up at the top of the offset feed, and that reflector is an 8-meter reflector, which is the same size as our 8-meter dish at Heathcote. But I was amused by that our dish, which we think is wonderful, is just the reflector in the Green Bank telescope. They can swing that. They can swing actually a horn into place, so they can do a direct feed instead of reflecting down to a variety of horns lower down. They can put a direct feed horn in there as well. That's an amazing piece of technology. One day I'd like to come to the Eastern Conference and actually have a look at it in reality. I gather there's the Grote Reber telescope there as well. So that would be a great experience, but not yet, let's put it this way. So there are some updates from me about reading, and that I would highly recommend that course from Jay Lockman. And going back on the space science stuff, if anyone's got any resources on space science, that's sunspots, coronal mass ejections, the implications for what goes on Earth, just send me an email, and I'll build it into the presentation. So looking around the screen, watching the time, I'm all right for time at the moment. Duncan, you're next on my screen. Do you have something that you can share with us?
Well, I've been mostly out of action for the last 2 weeks due to flu or something, some virus. I've been basically still taking data on via the Pulsar. I think I might have mentioned last meeting we submitted a paper about the 2.4 meter detection, waiting for the referees to come back on that. And I'm plodding on with some mathematics to look at the how I can improve the detection algorithm for glitches. In the last couple of weeks, I've also been across to Canberra to have a look at a 10 meter F on D of 0.3 dish, which looks like, having surveyed it, it may well come out of its current state into an operational state in the next 2 years, and I think that one will probably look at passive radar or bistatic radar for looking for PHAs, potentially hazardous asteroids, and yeah, so at the moment that's going quite well. Got a few students over there interested, not from astronomy, but from conservation of large structures. So they're having a look at that, and we'll be able to walk them through over 3 days with a colleague of mine who's actually leading it, looking at going through a site that's not been maintained, working out whether it was viable, looking for the structural issues, surface quality, and how we get this machine, which has been basically at the mercy of the wind for 20 years, back into a stable state. And that's going quite well. So I should make some progress with stabilizing that instrument in the next 3 months. And then we'll go for the next part, which is to re-engineer that which is degraded. It has one of the impressive things about this machine is it has a massive DC permanent magnet motor, around about 6 kilowatts in it to move it around, but all the gear inside is suffered from years of moisture and dust, and some interesting wiring, and so that'll all have to come out. And it was a clear case of it moving around. It twisted off all the cabling between the azimuth level and the elevation level, got completely twisted up by many wraps and destroyed. So it's basically a strip job. So I think, yeah, it's pretty interesting. Bit of work. Otherwise, just plodding on with some basic infrastructure, and also looking at playing around with some frequency sources linked to atomic clocks. I have this little project to take very cheap SDRs, throw away their crystals, and actually use a frequent 10 meg reference and PLL, the phase lock loop, the signal to these cheap but low noise clock sources, and you can buy for very few dollars, and use those to actually synchronize the cheap SDRs. This is more towards building a slightly better version of my pulsar detecting gear for Vela. I think that's about it.
Very good, thank you, Duncan. Yeah, any questions from around the place? I made reference to your Vela Pulsar glitch paper that was in what's the astronomers?
It should be in PASA if we get through. There's always a bit of because this is a slightly different paper, it's always difficult sometimes to get through the journals, because they have sort of themes in the journals. So we'll see what happens.
I'll make a comment if I could. I'll post a note for you, Duncan, in the chat in a minute about a link to a fellow. His name is call sign, amateur call sign is N6GN, Len Elmore, and he's developed a circuit and everything for a GPS receiver, GPS discipline receiver system, sort of like open source on GitHub that you could have access to just for referencing. And also, I purchased some things from China that were used in the phone industry. I understand they're about $16 for a GPS receiver, so those could be a good inexpensive source. But this is a block NE8 type module, so I think it's a fairly decent reference for from the GPS side. But Glenn Elmore used the I forget the clocking chip, 5309 or something that supposedly does some averaging and, you know, looks at the thing over time versus crystals and gets a real accurate reference. But I'll post that.
I used a U-Blocks 8T, which is one of the timing systems I have here. U-Blocks 8T. It has for two things. First, for timing, but secondly, for a 10 megahertz frequency source. And one of the things I found with the U-Blocks output that was not clean, and so I had to actually put a voltage-controlled 10 megahertz crystal oscillator before I let the signal out, just to clean it up and stabilize it. And, at the moment, that's going reasonably well. So, yep.
Yeah, this board I'm talking about has an 8T on it also. That's what it is, an 8T.
Thank you.
Yeah, thanks, Bob. And I'm going to kind of bow out because I have to scoot off. Rich, do you want to take back the chairing and just run through? From this end, we've got Len and Rob to give their two penneth.
Sure.
And I'll just mention to Richard Flagg. Richard, you asked for email addresses. I'm still getting permissions from various people, but I'll send you a list of email addresses once I have that list complete.
Well, so, thank you, Paul.
Yeah, it's on its way, Richard. Thanks.
Thank you.
Okay, over to you, Rich, and I'm going to say cheerio and see you next time. Sorry to bow out so early.
Thanks, Paul. Excuse me. Go ahead, Len.
Oh, hi all. I suppose the last thing I did was to try and improve the focus of my. I've got a 2.4 meter sort of just behind me. You can just see it there. And I tried doing some improving the focus. I'll just show some results. It's a couple of weeks ago, but I was doing long scans of several hours, and I record the right ascension declination, the time, UTC time, and so one day I'll be able to put these into a chart. But I'll just share the screen if that's all right. So I'll run this. So this is scanning, of course, the Milky Way, and it was over a couple of hours. So it's highly filtered, and I've removed narrowband signals. There's a fair bit of interference sometimes, and just smoothed it out. So that's why it looks quite clean, but it sort of captures the essence of things. So that's sort of an example of some of the plots I'm getting. I'll show you another one, just for the fun of it. So you could see the two sort of Doppler things. So at some stage, I want to be able to sort of show where this is actually occurring in right ascension declination. At the moment, I'm just getting the telescope calibrated, focused, and making sure that what I'm looking at, I know exactly where in the sky it is. So slow progress, but sort of getting there, I think.
We hope to complement your results, Len.
All right, thanks. I mean, I was sort of reflecting, people sort of ask, what the hell is that in your backyard? And we had a real estate agent come around and sort of had a double take. The other thing is, I was an amateur astronomer in the optical domain when I was a kid, but you know, radio astronomy, even though I'm not able to see the stars that well in the city, looking at the sky in the radio domain adds sort of another dimension. You can see things that optical astronomers can't. And so even though it's pretty coarse and it's not very sharp sort of images, you're actually looking at the galaxy moving, and that is just, yeah, you can't see that with an optical. So I just think it is an interesting sort of branch of astronomy for people to be able to sort of do this and appreciate it just as much as, you know, I appreciated optical. I actually appreciate the radio, because I appreciate that I'm looking at these big structures moving around in the universe. So anyway, just a bit of reflection.
Do you have tracking at all, Len? Is that just fixed, is it?
Not yet, which is I'll do that another stage. I'm actually a control person. I develop tracking systems for large dishes, you know, 30 meters, and I worked on the parks tracking system as well. So that's actually my sort of bread and butter. But I'm not jumping at control, you know, doing something yet. I'll have a go at that later. But at the moment, it's good enough to position it and scan, and just get started. And I'll worry about the tracking later. Yeah.
I totally agree with Len's approach, because tracking tends to end up with introducing flicker noise into systems when you're moving, when it's moving. So it gets a little bit, unless you characterize your system when it's static.
That's interesting, Duncan, because we haven't yet experienced that with our 8.5 dish at Heathcote. So there's something we have to watch out for, is it?
Yeah,
Flicker
I think
noise.
so. I think you have to
How
watch
does it
out.
appear?
Pardon?
How does it appear? How does it manifest itself?
You can get problems where you take your the first. I'm going to say some mathematics, but take the first derivative of your polar pattern, and when you get a source in the side of that, and you start moving around and you're not smooth, you'll find a sawtooth starting to arise there. So confusing sources will start to put a not in the sweet spot, but outside will start to move up and down on the polar pattern, and you'll start to see changes in your amplitudes.
That's purely a function of the fact that you're making the dish move something or track something. So things around it get okay. Have to watch for that.
It's where the slope's strongest you'll find this effect. So if you get a strong source that goes through that area and you're moving the dish around and it's not smooth, you'll see these I guess sawtooths related to the position changes. And they have a characteristic for the declination as you track across the sky, because you'll be moving what's yours, an as an L. So you'll see it going up and down as you move
So
around.
it's definitely called flicker.
Well, I
Flicker
call it flicker noise because I used to deal with audio stuff. I think it's like people have different names, but it's the long time constant stuff
Okay.
that builds up at low frequencies.
Yeah,
Low
yours-
detector frequency, not low frequency of observation. It's
Yeah.
So
and you need a
what's
smooth,
yeah.
you
Go
need
on,
a
Len.
smooth sort of drive as well, so that you're not shaking the dish as you're moving. And
Yeah.
so it takes a bit of thinking through the mechanical
Well,
aspects of it.
with our 8.5 meter dish, we've got a kind of a balance point. You've got a 1
Mm.
ton dish, and as you tilt the dish over, it goes from a pulling on the jack screw to a pushing on the jack screw. There's
Yeah.
sort of an inflection point. So we get a sudden transition that occurs there too. We have to be careful
Yeah.
of.
Well,
So this flicker effect goes away, does it, Duncan, if you just drift scan, for instance?
Well, you're not doing it. You're not moving antennas, so other than shaking by wind,
Right.
yeah, it's
Okay. I'll
What
have
do
to
you
make
think,
sure
Len?
that team are aware
Yeah.
of that.
Well, I mean, I've done a lot of, it might be good to chat too. I've done a lot of control for large dishes, including, avoiding resonance and all that. And the gears getting not removing the backlash by having torque, shared torque is sort of a common way. So, the gearboxes at Parks had a 180-degree backlash. So you have to have a scheme of having the gears sort of meshed up against each other and then smoothly transitioning, all that sort of stuff. It's interesting. But I just wanted to start observing. Not. It was hard enough. Sorry.
Yeah.
Go
Remember, Parks has got a very small beam, so when you move off a source, you really know about it. Whereas
Yeah.
you've got smaller dishes have this luxury of a bit of error.
Yeah. I've got about a 6-degree beam width.
Our 8.5 is about 1.4 degrees, so it's getting a bit tighter.
Yeah. And it does depend on the sensitivity. You can get what they call confusion. That is where you start to blend two, say, point sources together because of your beam. So you probably need to know something about the point sources in the sky, and there's lots of surveys around where the point sources are, and you run your beam across that and convolve it so you can see where sources will come in and go out. And the convolution, sorry.
I guess that also gives you some idea of the symmetry of your feed horn and the whole system too, doesn't it?
Yep.
If you go across it in different planes.
Yeah. I guess I've got to say, large numbers times small numbers still give you significant numbers, and that can introduce things into the systems. So the sun coughs, you'll see it in the side lobe. Anyway, I'm going to shut up at this point.
Oh, thank you. It's very much appreciated, though, Duncan. Thank you.
Another question is, are you doing drift scans? Because you just need a point from at 180 or north, and then use sidereal time to record your data, and then you've got your right ascension.
Yeah.
And you know how to calculate declination from your latitude, right?
Oh, I use a routine that converts as L to RA dec, given my lat long. Yeah.
Great.
So so the idea of having a movable dish is mainly to get the dish to another position so I can scan. That's where I'd use a drive. Otherwise, at the moment, I have to go at the back, move a screw, and then then come back. And I've got a inclinometer to measure the Azel. Yep.
Yep. That's the way we do it too.
Yeah.
All right. Any other questions for Len? So he's got to knock on the door anyway. Okay. Robert.
Everything's on. Can you hear me?
I can. I usually talk to you at 4 a.m, so I'm it's nice to be that you're awake.
Well, what we've done is I'm out at Waruna, where the optical observatory is, and the antique radio, the antenna sitting out in front of me right now. And like I commented before, we went through 4 seasons in about an hour up here, type of thing. But anyway, so for me, what I've done is restarted the scope in a box in the backyard. And, a couple of days ago, Ted and I went through and set up, it's still working, but I'm using antique software. So I've re-updated all the software and just sitting, in Sydney scanning while we're here in Australia. And, that seems to be working. What I've done is I've received an Alex Pettit Yagi antenna, and I have, some more electronics. I like 3 or 4, SDRs with all the, sawtooth and all that kind of stuff, sawbirds, filters. So I'll eventually, upgrade to another one. And I like the conversation about the, syncing with the GPSs, with the oscillators, because eventually, want to try and do an interferometer with the 2 radio telescopes. Okay, so another thing that's happening is there's a supernova coming up. So I've been looking at, M7, where they claim the supernova is going to occur. And I haven't seen it yet, but I keep looking for it. Okay, and what else is going on? Out here at the observatory, the tracking mount and the opticals are in there, and waiting for the weather to clear up so I can get the the alignment going and start to do some observations with it. What else is going on? In a couple of weeks we're off to South America. We're going to go, Patagonia to observe the annular solar eclipse and go see the petroglyphs and the marble caves and that type of thing. And then up to San Francisco, and still looking forward to going to Colorado to use your antenna there, in November sometime. Haven't heard much about that, but hopefully that'll be able to do that. What else is going on? Once the optical is going, I can point my spatial solar telescope at the sun, and start to come up with pictures with the corona, and the prominences for that, with the solar maximum, activity maximum coming up. And I keep taking pictures of the sun and the activity that's going on up there. And I'm certain there's a lot more to talk about. Oh, and by the way, if we do the history of us, of radio astronomy, don't forget the guy from Chicago that moved to Tasmania, about 100 years ago. And and there's a whole museum in Tasmania. And don't forget him. And also the
Road Grieber.
Pardon me?
Road Grieber.
That's right, Reber. Yeah, yep. I've seen his museum and at the radio telescope there. I've heard the Vela Pulsar, with that, the audio part of it. Yeah, it's way cool. So outside of that, not much else. Still cold out here in the hills. Any questions? Good, thank you.
All right. Thanks, Robert. Roger Heap. Oh, you're on mute.
That's
There you
better.
go.
So sorry, I slept in. I've been a little bit crook, so I'm a little bit croaky at the moment. Nothing really to report from me. I sort of the message came up in the email the other day, and I said, "Wow, it's been a whole month since the last one." Life has been busy. Yeah, I keep on not running into Robert. You're obviously going to Wirrina on the non-new moon weekends. So I went down there last new moon weekend, but there was not many people around. I'd still like to see. I've never actually seen your scope in the box working yet, so one of these days would be good. Yeah, hopefully next month. Actually, well, I'm pretty busy couple of months coming up now. I can't see much radio astronomy happening, but by the end of the year, I'm hoping to start ramping it up a bit. I've got a couple of projects here that are just sitting there half done. So yeah, apart from that, it's about all from me, really. I'll see you next month.
Great, thanks. Richard Flagg.
Yeah, so is Rob, you still online there, Robert?
Oh,
no, he's gone. I
no.
recognise where he was. I know
I'm
that.
still here. I'm still here.
Okay, so what days do you go to? What days do you go to Wirrina? Are you going on this weekend on a regular basis?
I'm here now. I'm here at
Yeah,
Wirrina
but
now.
it's
Next weekend is the normal weekend. And I'll be here next Thursday.
Right, okay. So when is it? The new moon's coming up a couple of weeks away. So I've been going there on the new moon weekends to the optical people.
Weekend. It's not
next
this
weekend
weekend.
Already.
Weekend.
Oh, where's the time going?
No, that's for sure.
Okay, well, I'll see if I get there next weekend. I'm not quite sure, but I'll see you there if you're there.
I'll be here. See you here.
Okay, see ya.
Okay, thanks. Richard Flagg.
Nothing really to add. I'm just enjoying hearing what you folks are doing. Thank you.
Okay, thanks. Helen.
Hi. Has the conference been posted yet? For some reason, I just can't seem to latch onto it, and I'd like to see it.
The YouTube on YouTube, I think I got about 5 to 7 of the presentations on YouTube. The other ones were lost, so we're trying to regroup and get the people that that did not get recorded to redo theirs, and then we'll post them.
Okay, great. Yeah, for some reason, I even checked my spam. I never got the passcodes or the ID, but we'll figure it all out here eventually.
Just go to the Sarah YouTube channel, and there's the playlist for Eastern conferences on there.
Okay, sounds good. I appreciate it. Thank you.
No, glad to have you. Let's see, Don Latham.
Hi, I'm having unstable. Can you hear me at all?
We can.
I'm having unstable internet because I've got a thunderstorm over the top of my house. I've been elected to the board of directors, I guess, and I want to assure you that I will not be instigating a hostile takeover.
Oh,
outside of that, nothing.
You don't realize I'm allowing hostile takeovers of the presidency if you guys really want one. All right, you guys can take the president at any point in time, and I'll step aside. Never mind. I'm just kidding. Okay.
No,
thanks, Don. Let's see, what am I missing here? Jason, are you?
I did have something. I heard something about DC drive motors for dishes. Who was it that was talking about that?
I think Leonard Duncan, right?
I was talking about a DC drive motor.
Yeah. I've got some drive H drives that I developed for the Canadian people before their dish thing fell apart. If you've got old style drives, maybe you could use them. They're good for a kilovolt at 400 amps. So they should be able to drive your DC motors pretty handily.
Thank you very much for the offer. I'll bear that in mind. I'll talk to people.
Yeah, because if you've got the really old style stuff, it'll have amplodines or something like that, which are a pain in the butt.
Yeah, this one used an SC, had a 3-phase auto transformer, then a black box, which I believe had a bunch of SCRs in it. And after that, we're still going through the documentation. This is, I think it's called Scientific, I can't remember, Scientific Atlanta dish made in 1987.
Oh, it should have a modern drive system then.
Yeah.
Yeah, Scientific Atlanta is pretty good stuff.
So I'm learning.
Okay, that's just an offer. If keep it in mind if you need something like that.
Thank you very much.
All right, and Jason.
All right, so yeah, I just the past day and a half, I've finally dove into playing around with the Skynet 20-meter dish at Green Bank, and that's a whole lot of fun. So I'm going to show my results here. I basically retraced the steps that I took with my small setup using that to see how it would perform in comparison. So I'm going to go ahead and share my screen. And let me see here if I can. There we go. Let's do screen. All right, can everybody see my screen?
Yep.
All right, I'm going to start this. So basically, I've been retracing my, like I said, my steps that were presented in my paper with my 3-meter dish, and I've been using the 20-meter dish at Green Bank. It's very straightforward to use. It took a couple tries to figure out exactly what I wanted to do, but my observation settings, I'm using the L-band receiver to do hydrogen line reception. I'm capturing spectra. I put it on the high resolution setting. My first one was a low resolution scan, and it just didn't have enough frequency bins to really show detail in the spectrum. So I went to high res, and then I'm using on off scan mode. So I'm taking time on target and then time off target, sometimes multiple in a row, to build up integration time on source, and then using the off target as my reference. One of the reasons for that is that it suppresses a lot of the local Milky Way signal, so that it's not so that it's less of an interference to the extragalactic sources. I ended up using 10 repetitions, 15 seconds on, 15 seconds off, times 10. So basically 2.5 minutes on and 2.5 minutes off. And I've discovered, which you'll see in a minute, that was way overkill for this 20-meter dish. So the first thing so I'm going to put these in order of brightest to dimmest. M31 is large enough that I couldn't actually get the whole thing at once. So I actually took 3 points across the span of the disc. So I did the blue shifted side, then the center, and then the red shifted side. And as you notice, that little spike in the center right around 1420.4, that's what the residual left over from the Milky Way that didn't get completely removed by the off target reference, but it did suppress it quite a bit. And then I took that data and summed it in a spreadsheet and plotted it and did some background correction. It doesn't look very good because I've only got 3 points and they're real distinct, so I'm not really getting a full integrated spectrum. So let's move on to one that acts more like a point source. So M33, it turned out beautifully. And again, you can see the Milky Way residual signal there as the spike in the middle. And then I pulled the data in again to Excel and used on one of them, I actually used a slight linear correction. So off to the left, you'll see basically I have up to second order polynomial fits if I want to flatten my background. As you can see, I only needed basically a vertical correction on the Y one. So I believe that the two signals are cross polarized, so you get two polarized axes in that receiver. And then M101. This so the reason why the background's a little more messy on this one, or a little more curved, is because M101 is the first one that I did with this longer time, and with the 2.5 minutes on, 2.5 minutes off. And when I did M101, I did one 2.5 minute segment on, and then a second 2.5 minute segment off, and that was it. And so there was a lot more drift in that time of the background. Since what I did on the others was I actually I would do 15 seconds on, 15 seconds off, and do that 10 times in a row to build up the 2.5 minutes. And as you can see, it keeps the background a lot flatter because you're correcting more often. Again, the little blip near 1420.4 is the residual Milky Way signal. Now, I just before I came to this meeting, I was playing around. I was actually queuing up measurements from my phone while I was out running around town. I actually I wanted to see what would happen if I used shorter and shorter exposure times. And so I went to 30 seconds on, 30 seconds off. Then I went to 10 seconds on, 10 seconds off, and then 5 seconds on and 5 seconds off. And you still have a clear profile, even with just 5 seconds on target, which is amazing. Okay, so, and then this is, again, this is the corrected, cleaned up version of the data. I downloaded the data files and dumped them into Excel, and then I can do some nice plotting work with them. Then M74, and then we got M81. M81's interesting because it's the Milky Way sits right in the center of it, and so it's hard to get a complete pristine profile because you have that Milky Way signal right in the center. And what that basically means is that its proper motion is almost zero. So it's straddling the Milky Way signal because it's basically sitting still from our perspective as far as radial velocity goes, or it's very small velocity. And then here's NGC 2403. Oh, by the way, if you're wondering why there's two identical plots, for some reason, when you use high resolution mode, it has the option for two different center frequencies, and I was only using one, so I just programmed them both to be the same. And then here's Holmberg 2. And that's it for this presentation. So yeah, so I've been playing around with that 20-meter dish, and it's really, I was able to do those quick plots where I was doing 10 second, 30 second, 10 second, and 5 second exposure times. I did those from my phone while I was out running around, and I actually accessed the plot from my phone and email it to myself. So I didn't even have to be on my computer to do it. I was able to do it from my smartphone. It was it's really cool. And then I was it was funny because I was sitting down having a beer and eating my supper, and I thought, well, let's try 1 second. And then it queued up and it did that ready thing, but it wasn't active. And I was like, oh, somebody else is using it. And sure enough, somebody started a 2-hour Pulsar track. I was like, oh man. So, but I'm kind of curious to see what 1 second on will look like. I think it'll still show up clearly with even just 1 second of exposure, which is amazing. And what that proves to me is that I can survey a whole lot of the nearby galaxies with this thing with very small amounts of time and not eating up a lot of the credits. I mean, I can use a handful of credits and get a decent spectrum. So
That's excellent, Jason. Is that presentation? That's something you could put on the chat?
yeah, sure. Yeah.
I'd love to get a copy.
Yep. Yeah.
It's impressive
definitely.
too, like you say, controlling systems from an iPhone. I was able to do that with our dish up at Heathcote too, and it just blows you away, doesn't it?
Yeah. Well, it's kind of funny because yesterday was my birthday, and it was kind of like my birthday present. I got to play with this big toy, you know. It's like,
Many happy returns.
but yeah, I am in the process of one of the things that I came away from the conference with is they were saying bring your dish next year, and I wasn't able to bring my backyard portable collapsible dish because it was just too big to fit in my car, and also it's been kind of deteriorating because it wasn't really weatherproofed. And so the first thing I did when I got back was start designing and building a leaner, meaner version of it that's weatherproofed that I can definitely bring next year. And so I'm putting it through its paces now. It's 2.5 meters instead of 3 meters, so it's slightly smaller. It's got a 0.27 focal to diameter ratio, so it's a little bit more curved to try to with the smaller size to try to sink the feed into the dish more and keep the ground interference down. And so I've been actually doing for the past 5 nights in a row. I've been doing M31 scans, and I am. It's definitely not performing as good as the 3 meter one, but I mean it's working. And so now I'm actually starting this evening, or well, actually early tomorrow morning, I'll be doing my first M33 scan with it and see if I can, after about 4 or 5 days, if I can get a clear profile of M33 with that.
So do you get the timing data to the GPS reference time that they have in their network there with your files, and are they coming in as SPITS files?
Well, probably. I mean, I didn't really care about timing though, because I was just looking for a spectral profile.
I
So
was just thinking though, if you got timing data, then a couple of different people in different places could look at something and do
oh yeah. Well, I think actually let me bring up, I'm going to share my screen again and let me bring up one of the files because just to so there's this they call them SIDS files, I guess. But there's also just ASCII files that have the data in them. And so for instance, let's see. So my M101 file, let's see here, is this? Let's see if I can. Okay, so here's the M33 file. So there's a bunch of stuff in the header. Can everybody see it?
Yes.
Yep.
And so it does have the date and timestamp on the file. And then yeah, and then all the settings.
It would need to be more accurate than just the header having the date and time. It would need to have, like every data sample should have a time marker on it.
Oh, okay.
And that's a kind of a FITS file format to have the header at the top and then follow that with the data. So it may not be called an FITS file, but it sounds
Yeah.
like that's what you got there.
Yeah,
Bob,
well, and because I'm using spectral files, this data represents integration over 2.5, well, actually 5.5 minutes worth of time. So
Bob,
it's
the Skip Crilly did a YouTube on this very subject about how to get the raw data from pulsars and from various other things. And so there is a way to get this data, but this is more the common users data profile that provides, but there's also a way to get the internal raw data at whatever you want. And he did there's a YouTube, look for Skip Crilly on 21 meter dish, and he's got how to get that detailed data.
That's great.
Also, you guys, everybody in Australia, we've just got the ability to provide for Sarah members the access to this 21 meter remote. So you guys can, as Sarah members, it used to be that it was just had to be U.S., but because of the national, the way it was funded, but now we've got rid of that. So if you email Steve Zekas, and his email's on the website, then he can give you the password, and you can do what Jason's doing. But you can do pulsars, you can do hydrogen, you can do any objects. And you can do it remotely on your phone, just like Jason's doing. So you guys have that access as Sarah members, and we're funded the account so much, so just don't use up all the time. But we've never used all the time we paid for. So you guys.
I was wondering about that because when I realized that that after doing several of them that 5 minutes of integration time was way overkill. I mean, it was nice and clean, but I did that little experiment just about an hour ago where I cut it down and down. So what I'm wondering is how do I judge if I'm using too much, because I don't want to hog it, but
Well, if you're worried about it, send an email to Steve Zekas and say, hey, it's okay if I sort of allot 30 minutes or whatever for this month, and he'll tell you how much. He knows what the account numbers are. And as we're saying, I've played with this thing a couple of years ago, and I was using all sorts of time. So don't feel too guilty about that. You're doing really good work, and this will all be up on YouTube, and everybody will be happy about it. So.
Well, yeah, now that I figured out how to do decent profiles with just 5 seconds of integration time, I mean, I can go after a whole lot of galaxies and not use a lot of time. I mean,
I think that's what everybody finds out is that they don't need as much time as they originally planned, and it gets less and less for more objects. I do have one question for you, Jason. Rob Lucas was talking about observing M7 for this supernova. And we all know that supernova is probably not going to add a lot of hydrogen, but can you pick up M7 doing this method?
I don't know. It's M7 is just a stellar source, right?
It's a galaxy.
Oh, okay.
And I don't know what kind of hydrogen source or anything. I'm just saying that the reason they're observing that is because of the supernova. And if we can get some baselines before, and when the supernova happens, you'll have plenty of opportunity to go observe it after the supernova. But it'd be nice to get a couple beforehands to see if you can pick anything up.
Rich, M7 is an open cluster in Scorpius.
Oh, it is? Is that what? Oh, it is.
Yeah. Yep.
Okay.
But that's where the supernova is supposed to happen, right?
Yeah, it's a messier object, but maybe that's the star that's going to go nova is in that area, but it's not part of the cluster.
Okay. Well, see if you can pick that up and see if it has any, maybe it has some kind of a signature we can pick up. But that'd just be fun to look at, and then maybe we won't get anything, but looks like what you're doing, Jason, is the closest thing to being able to observe it with with a telescope.
Well, big explosions usually generate lots of RF, don't they?
They
Across a
don't.
broad spectrum.
Yeah,
They
it would be
don't.
broad spectrum instead of a profile, but yeah.
Yeah, the problem is they don't generate much hydrogen.
Yeah.
So
Yeah.
we may not see if we're observing at 1420, we may not see it.
Oh, you see a continuum object that will evolve.
Yeah, you see
Time.
you'll see the whole background go up and down probably,
Yeah.
but yeah.
Yep.
Yeah.
Okay.
What is this forecast to be? Is it a type 2 or is it supernova?
I thought it was actually isn't it supposed to be a reoccurring nova with a
Okay.
whole period?
Yeah.
It occurs every 40 years or something like that, but it may be a little optimistic to think it's about to happen too.
Yeah.
Well known.
Well, imminent could be the next
You're
few
talking
years.
all about M7. I thought it was T Corona Borealis, which is
okay. So maybe
that's the recurring 40-year.
Okay. So it's two different things.
And I'm guessing that's a nova, not a supernova. So
Yeah.
how are we predicting a supernova? Wow.
Yeah.
I
I don't think you do.
I was just saying, maybe we ought to sync up with Robert Lucas and say, okay, Robert, we'll observe, and because he's going to be observing it either optically or with some kind of a telescope. So, okay.
I wanted to mention one other thing on the stuff, Jason. I looked at this data a little bit once before on that system quite a few years ago, and it looked like to me there was a big opportunity to do just sort of mining of data that's there, because you can go out and pull down data files that other people collected too, right? And so if you can interpret their header files, you wouldn't even have to set up a scan and potentially even get like historical information on a particular object to compare with, I think.
Yeah, absolutely.
And maybe even data from other scopes as well. I think some of the bigger scopes are out there as well, if you know how to get to it.
There's a paper just come out on it's XRIV talking about the WOW incident, and they're talking about subsequent. They think they've identified other less bright objects. It's good. It's in the scientific media at the moment, but it looks like maybe cold hydrogen clouds got pumped by something behind, and then basically a single pass maze, and you got the WOW incident was about 70 seconds of that, and then it faded out. So it's interesting times for transients.
You mean that just happened within the past hours too? Is that right? Is that what you mean?
Well, the WOW spot, I think, a WOW incident in 1977 only lasted for 70 seconds, if my memory is correct. Okay. Very narrow band, slightly blue shifted. And yeah, the people are still trying to figure out what it was. But I think somebody from Arecibo had been mining and may have found some more less bright instance of this sort of phenomena. Of course, I think a lot of people are thinking it's pretty speculative, but the universe is a weird place. I'd rather not tell the universe what it can do.
Okay, Jason, you got anything else?
No. I mean, my plan is basically to retrace the reference surveys that I've been using for my backyard project and just hit each one of those, down the line, just kind of go on a safari hunt, basically. So
sounds like you're going to get spoiled with that big dish.
Yeah.
Okay.
Yeah.
All right. Thanks, Jason. Bob, you got anything else?
Rich, I want to rewind back to Skip's YouTube. Is that on the Sarah Sarah YouTube world or his own?
Yes. Yeah, look
On
up a
the Sarah. I
Acryli
will look that. Okay, thank you.
21-meter dish. I think is in the. I just saw it pop up here just recently. Someone viewed it.
Yeah, my only other comment is I'm working on muon detectors, like the cosmic watts type detectors, and I've got 3 of them that I put together, and they're collecting muons. But the way that project was set up originally, they collect data back into an SD drive or on a screen that you can watch. And that, I don't want to do it that way. I want to collect it so that I can log it and do plots and things later and correlate that with other things that are happening. And if he did get a nova, then I'm expecting that to really go wild. But so I'm writing Python code to try to communicate with these things and collect data and put it back on another computer so I can log it. That's my current project anyway.
Okay, thanks, Bob. Okay, Ted, you're it.
I don't think I have any real news. Ezra is recovering, and I'm working on new ideas. How can I make it even easier for folks to run Ezra? And then wouldn't it be great if Ezra could control a lot of different kind of hardware? So SOAPy drivers.
I
Watch
do have
this
a.
space.
Okay, I have a question. Since Len and Duncan were talking about hydrogen point sources, which there really isn't too many of them. The one picture we have with that you have on the southern hemisphere, where you've got the hydrogen, the galaxy, and then it dips into the southern hemisphere. It looks like they've got a big, broad area that they can be observing and guarantee that they're getting something with the Milky Way. Right now, what it's supposed to look like with that dip there is, I think we have the radio eyes picture. I think that. So Len, that's the picture. See, this is what we're getting on northern hemisphere. But if you guys can pick up that bottom half, there's all
Okay.
your. That's where your data is.
Yep.
And
We'll
indeed,
do our best, Rich.
I suppose one question was, which frequency do you choose to put here? I mean, this would be at a particular frequency, but we've got. So what? How do you draw this? How do you just pick the most prominent frequency?
so we're simply plotting the power of 1420 megahertz.
Oh, okay.
I think it's called column density, isn't it? So it's a broad band. It's not considering Doppler shift at all. It's just grabbing the whole spectral energy of neutral hydrogen.
Okay.
We are just looking at power here.
All right.
Now you can take that same data and now play with galactic arms later in the programs. All that Ezra stuff.
Okay. Anybody else have anything?
I do.
Yeah,
yes.
go ahead, Steve.
Let me see. I've got to open it up first. Where's my report gone? Righto. Share screen. Back onto Zoom. Share screen. This thing. I did a survey at our property up at Heathcote, 20th of July this year. We've installed a discone antenna. Now, I don't remember if I've made a presentation to Sarah about this antenna. People familiar with a discone antenna? It's a commercial product.
It receives many frequencies.
Yeah, it's a broadband VHF, UHF antenna. This particular one will go from, well, that actually works all the way down to 500 kilohertz. You can pick up AM broadcast on it, but it's pretty much resonant from about 20 megahertz, 25 megahertz up to 3 gigahertz. But I'm not so sure omnidirectional receiving antenna at 3 gigahertz is all that interesting. But it's a disc which is made up of horizontal radials, and then the cone is the downsloping radials. But there's also an additional feature added to this one with a vertical whip and a base loading coil, and that's for the 6-meter amateur band. So this is also optimized for transmit at many of the VHF, UHF radio amateur bands. But I recommended to the radio astronomy section that we buy this antenna and we use it for multiple purposes, not the least of which would be to keep an eye on the localized interference around our radio laboratory. This is our setup at Heathcote, where our computers are inside that Faraday cage, and our dish is behind me. I'm facing north in this particular photo. So one of the concerns we've got that's developing up at Heathcote is the generation of localized radio interference. There's a big program going on with the optical side of our club to install remote access astrophotography equipment. And so 24 hours a day, there's new installations going in quite close to our dish, which have computers running, tracking telescopes, astrophotography. And I've walked past these installations with portable test receivers and picked up large amounts of radio interference. So I thought it'd be worth to sort of get a baseline of what that's doing using this receiver antenna several meters above ground over our radio installation there. So I'll put this up on the chat. You can download a copy. I won't go into great detail about it, but I use a software-defined radio that we have, our RSPDX. What's that now? I think that's a 14-bit resolution software-defined radio. And I just took spectral scans at different frequencies, and I described them here, and then show the output of the receiver using waterfall display and spectrum display. The SDR generates a few of its own internal spuriae, which you have to be aware of. But it was an interesting way to look at what's happening up there on the radio spectrum, and particularly in and around the frequencies that we're interested in. And there's some horrifying signals that appear to be intermittent. This kind of pattern of noise that just jumps around, that's at 20 megahertz. That's at the Jove frequency, sadly. So that sort of interference pattern was appearing at multiple frequencies across the spectrum. And there's also this kind of thing at 52 megahertz, where there's an enormous number of harmonics from some sort of digital system covering the entire spectrum at 50 megahertz. And then there's things that come on and off, like these lines, these spectral lines, these vertical lines in the waterfall that appear for several seconds, and then you'll see a quiet period up the top where there was nothing. So there's a number of problems for us to solve. This is up at 435 megahertz. So the spectrum at that particular range of the amateur band was pretty quiet for several seconds, and then something gets turned on and it's broadband interference across the whole spectrum for many seconds. So we don't know what that is yet. We've got a strategy in place where we're going to switch things off in our own radio laboratory, just make the whole lab quiet, just this receiving system with the disc cone antenna, to see if we've eliminated that local source of interference. So it could be something in our own installation that's being generates this interference. But at the end of the day, it may also be something related to these astrophotographic equipment that's been installed. So this is a particular spectrum now, right up at the neutral hydrogen. There's some sort of funny noises going on there. That particular spike is related to the SDR itself. But it's close to 0 dB gain on that antenna. But it indicates that at that particular time I did that study, there wasn't any significant interference on neutral hydrogen. Not that that's the case when we have star parties and people turn up with their cameras and their computers and their mobile phones. So it's a baseline. I'll post that onto the chat. And it's going to be another issue that the radio astronomy section of the ASV is going to have to continually deal with. And we've got buy-in by the other groups, the optical groups, and not totally antagonistic towards us. We work cooperatively, hopefully. And there may be needs to put filters, inline filters in the mains, because we haven't done that yet. There may also be the need to do timeshare arrangements where how can you do optical astronomy and astrophotography in daylight hours? So it might be perfectly reasonable that they turn that equipment off, because currently they're running at 24 hours a day, which is a waste of power in itself. So that's an issue we've got to deal with. I don't know if you guys have got similar problems, but it'll be watch this space, and we'll report back to Sarah of our findings and whatever else we can find in that situation. Thank you.
I mentioned to you that this guy N6GN that I posted a link to some of his work earlier. He's done an antenna just like that in the past and written articles about it, and so he's got the homebrew information there if you've got one already. But one thing I noticed about it looked like you needed to really use an antenna tuner, a matching network on the thing. Is yours real broadband, or do you have to adjust it as you change frequencies?
I wrote a report on this, Bob. I actually was very fascinated by the technology of that antenna, because I'm an RF engineer. So I was fascinated by the technology of a disc cone. So I went right into the theory of it, did research papers, the original design papers for the antenna. So a lot of it seems to be lost in time now. It's a bit mysterious how it was developed. So it's a bit of a combination of a proper dual cone antenna, but it's not quite the same. I think it's an engineered antenna rather than a designed antenna. And the engineering comes into getting the VSWR as low as you can at the emitter frequencies, or frequencies you're interested in transmitting. And that's what this one has done. It's got dips in the return loss right at the emitter bands, and you get better than 2-to-1 VSWR. Sometimes it's about 1.5-to-1 VSWR on the emitter bands. But it is necessary, if you're really serious, to put an aerial tuning in there if you want to transmit into it. But as a receiving antenna, it's better than 2-to-1 pretty much across its entire spectrum. So that's perfectly good as a receiving antenna. Very, very broad band.
Good.
My experience for hunting down interferers at short and long range is you need a small Yagis to actually triangulate the interference, and also you need to log the spectrum. I used an R1000 receiver, which was programmable, which just hop across I think wideband FM signals this is 20 years ago, but that was the way I tracked down the users, and as Len just pointed out, it's quite interesting to find out their profile. He's identified microwaves. We were always aware that the kids getting off the bus, picking up their mobile phone and talking to mum, or and you could see the I guess human activity profile.
Yeah.
I did notice you've got a aircon up there. That's probably got a processor in it somewhere as well.
Oh yeah, look, I've one of the ways I look for interference is a low frequency receiver I built, it can go down to 100 kilohertz. So that picks up switch mode power supplies very readily. Yep. You only have to be within a few meters of that aircon and you hear it buzzing away.
Oh yeah.
And whenever you hear a switch mode power supply, you know that there's harmonics of that, the potential of it at least. Now I'm just quickly trying to find a copy of that file so I can put it up on the system. Here we go. There we go. So that's.
I've seen 16 megahertz digital oscillators put out harmonics into just above 1 gig, sharp edges, and the more gear we've got with sharp edges, and I mean, I'm talking about picosecond edges, they're going to radiate broadband.
Yep. Yeah, look, we've got a number of things on our radio astronomy installation that are not really radio astronomy. As the years went by, the team were interested in lots of things, earth science, and also facilities to help the optical guys. We have an all-sky camera, and these things take an image and then they update them onto the web. And the recent one because the original camera broke down, so a new one was installed. So the camera's up above the roof of that building that I showed in the presentation. That's our radio laboratory. The camera's above the roof, and right below it is a Raspberry Pi that does the data processing to send it onto the web. So that's it's in a shield, but there's shields and there's shields, isn't there, Duncan? So that could be one of the intermittent patterns that we're seeing in the interference, that the Raspberry Pi comes on every so often and updates the image to the web. So we've got to switch things off. Go on.
Oh, short story about this. I got introduced to noise from digital SLRs in a very dramatic way. I was trying to fingerprint the observatory building, which we'd put a shield around, which was giving us another 13 or 15 dB isolation from noise generated by computers and digital systems inside. And it was going fine. I thought, oh, that's great. I'll take up digital SLR and I'll take a picture of the screen. And that's where the problem started, because immediately I clicked it, the spectrum went. I got in the the rear lobe of the sensing antenna, and I realized that the digital SLR, in its process of taking the picture, generated a whole lot of RFI.
Yep. You can chase your tail, and RF finds a way to get round corners and go up somewhere else as well.
Yes.
You can try a shield, but then it can sneak past things. And I've worked with this stuff because I developed two-way radio products, and you have to have a metal box to mount the radio circuitry inside it, and those boxes have to comply with Australian standards, international standards as well. And one of the compliance requirements is case radiation. So anything inside the box is not allowed to radiate and create radio interference. So that's where you learn a lot of lessons about feed-through capacitors, shielding of individual modules, and interconnection modules between one and the other. So I've got some experience in that area, and it's not an easy thing to solve. I've just uploaded another document, which is the report I wrote on the disc cone antenna. So I hope that's interesting to you guys as well. If you,
I had some people build an RFI cabinet for me, or for the project, and one of the guys says, "We're seeing leaks out of this RFI cabinet." And I said, "What did you do?" "Oh, we had an optic fiber going through it, and then we stuck a coaxial cable through, and it had a long choke. I had a waveguide beyond cutoff, basically a choke." And I said, "Why do you put the cable through?" And he said, "Well, we need to do this." And I said, "Well, that defeats the whole purpose of it." So I've always sort of taken a Matushka doll approach of having containers within containers within containers. And that's because I know that somebody's going to come along in the future and want to put a cable, not knocking a tradie coming through, but he needs to put a power line through. He'll knock a hole in the outside shield. So you've got to do in my view, a multi-layer approach, but that's just my experience.
Yes, that's very true. Yep. Well, the problem gets worse. Sorry.
Thanks for your report.
Go ahead, Bobs.
Yeah, I want to look at it, your report. Thanks for it.
Yeah, I've put the disc cone report and the radio interference survey report onto the chat. The disc cone report was a challenge for me. I did it earlier this year because I never really got to answer the true question about how that antenna was designed. And I think to some extent it might have been commercial in confidence, and they don't publish such detail. It is based on antenna theory, but then there's a few little tricks that I never quite understood. But it was fascinating to do that study. And I've got various textbooks of how you can calculate aspects of the antenna, but then they didn't always work. So at the end of the day, I'm not sure it matters. I'm using it as a tool. I don't have to design one myself, and it's doing a good job. And we're going to use it as a background reference ongoing to manage that property of ours up at Heathcote. Thank you very much.
Consider if you want me to put any of these in the next journal.
You're welcome to. Yeah, it's no problem with that. Go right ahead.
Good. Okay. Does anybody else have anything? A great session, guys, and we'll talk to you next month.
Yeah, thoroughly enjoyed this session. Thank you.
Thank you.
Very much so. Thanks a lot too. See you, Rich. See you, fellas.
Thanks.